Now let's get into this low level procedure call. So by the time this time we already have refreshed our memory about the high level programming. What is the expectation? What are the different features that we need to concentrate on uh, discussing this low level procedure call implementation. Okay. So first of all, processor need to support certain with certain feature for a function call. So there are some hardware dependencies there. Function and procedure call. First of all, how are we going to pass the argument? That is first question, right? We use A0 to A3 to pass the argument. Okay. Also, we can use the stack. Remember the stack part of the memory. Function implementation use stack very extensively. Okay, so you need to be very clear about the concept of the stack memory inside the processor. Okay, stack memory part inside the processors. Though remember again, memory, stack memory, heap memory, those are all software concepts. Those are all software partition or assumptions about which area of the memory is used for what purpose, right? So at the hardware level, processor and memory doesn't have any control or anything that actually suggests that or or prevent you from using any part of the memory as a stack or other functionality, right? So this is purely a software concept. But anyway, so so we pass the argument through this register, 4 register A0 to A3. We can also pass additional argument through the stack register. Again, this is the convention. We can later we will see one example in the next lecture that we we can pass, like, we don't really need to pass all of them, like this first four argument through A0 to A3 and then use the stack. Like we can pass like all like zero argument through A0 to A3 and just pass everything to the stack. Okay, or one argument in through the A0 and then or A1 or A2 or A3, and then rest of the argument will pass through the stack. We'll see that. Okay, but in general convention is this: you pass the four argument A0 to A3. Okay, you involve stack only if you need it. Okay, only if you need it. Then how do I transfer the control to the function in order to mean, like, how do I call the function? Okay, it is not something like we type in a function name and pass the argument. It is just not like that. We use something called JAL, jump and link, which is nothing but a jump, like a J instruction jump. But jump and link stores the next instruction address in the caller code in the register $RA. Okay, so this is one important thing you need to understand. So you're transferring the control, like, from one place to the start of the procedure or the start of the function code using JAL, jump and link. You could have jumped to that implementation of the procedure using jump as well, because we'll see a function or procedure is that start of that code is nothing but given with a label. Okay, given with a label. You could have do it through the jump, but point is that with the jump, after you're done with the execution of the function body, you will have no clue where you want to return back from the function. Okay, when function you are implementing. So JAL is the one you always need to use, which will store your return address where you need to jump back in a register called $RA. Okay, so let's say you are calling, you are jumping from a location, let's say 1000, like that, and then RA essentially will store 1004 when you are actually doing a JL from a location 1000. Okay, so it will store the next instruction address into the $array. So this is how you transfer control from your code or from your place to the function. Now inside the function performs the task, that is the black magic. Only when you are implementing the function, you know what is going inside in detail. Now return value result by convention a function right into these two registers, V0, V1. So there is nothing called a return, and you are capturing the return value in your main program or wherever from wherever you are calling the function. You only after you are done with a function call, then you check or access the result from V0 and V1. Usually functions returns one value. If there is multiple value, like more than 1, 2, that is the maximum, is the common cases that it will max return 2, not can. It will maximum return 2 values from a function, and those values are stored in a V0, V1. Like 90% of the cases, a function returns one single value, so V0 is usually used. But which one is used and what are the arguments, etc., that has to be very much documented in the function in terms of comment, right? So otherwise no one knows like what's been going on inside the function, right? And return to the now controller to the caller. Okay, so you are calling from an instruction which is placed at, as I give that example, from a memory location, let's say 1000. Okay, and after you are done with the function, from inside of that function, need to transfer the control of the program to the location which is 1004, right? Remember, like when we call a JL to our function, it's stored in the array your 1004, that location, right? So at the end of the function, then you can just do JR, jump register $array. So your array contains the return address, return point. When it goes back, the control goes back to that instruction of that memory. So just a note, when we are making this controls transfer and we're telling about this control is back to the caller and stuff like that, what physically it signifies is practically manipulating your program counter register. Remember, the program counter stores the address of the next instruction to be fetched, right? It is the purpose of the program counter. So JL and JR, these both are manipulating your program counter. So you can that means you can actually manipulate program counter, but not directly. Okay, you can manipulate, you cannot, what I mean, like for example, you can manipulate value of the S register or T register using almost every other instruction, like add or and or subtract or multiplication, right? That will go and store and load immediate, store immediate, that kind of things. You can go and manipulate a register value, but you cannot use PC in that context, right? So program counter is manipulated using only couple of instructions, like jump, for example, J, and then JL, and then JR. So mostly three instructions that you can manipulate the program counter. So when we are talking about transferring control from one place to another, that really we mean we are manipulating the value of the program counter. So that part you need to be very clear about, okay, how things are managed within the processor context.